YouTube? How is it going? I need a drink. I hope all is well. Boy, oh boy, what a freaking day that was. So this would have started right on time at 4:45, except for like literally, I think it was just about 2 minutes prior to the start time, the internet just freaking dies. I don't know if we had an outage or if there was some error in my network or something like that here at the house, but needless to say, I had to restart the modem, and I had to restart the, you know, the Eero whatever network crap that I got. Here we are now. So I jumped on hotspot on this computer so I could change the time to 5 p.m. as opposed to letting it run on and on and on and on. I have not had a chance to really do anything on this thing. I came in earlier today and it was just kind of get the knobs on. So I put some knobs on. I did not put the ones that I intended to put on. Yeah, right. It's the Illuminati. It's somebody saying, yeah, ye shall not make any noise yet. But here we are. Okay. So as you can see, I put some knobs on. They're kind of in an arbitrary position. This is the presence. This is the master volume. We'll have it down nice and low. These two are not doing anything yet. They're not connected. This is another volume control. This is my actual volume control. This is my actual gain pot, I guess you can call it. And that's my bass control. So before I do any startup kind of process, this is kind of like your last chance to make sure you get it all right. So you do not want to fudge this part up. So I'm going to kind of show you what it is that I do. And now I know in some of my other videos where I do this startup process, I do it a little more, you know, fast paced because I've already done some of that work. So in this case, I'm going to kind of show you in more real time-ish what's going on. It takes 5 minutes to join. Join the giveaway today. This could be yours. I didn't build this for me. I built this for one of you. So the rules are in the description. Grant Us Glorious Tone also has all the rules. We will have some noise today. I am pretty certain that this resistor is going to have a very short life right there. I'm second guessing the value that I chose. I mentioned yesterday I was shooting for between 20 and 40 volts on my bias supply. I think I'm going to be a little shallow of that, but we'll see. If I need more voltage, I'm going to have to raise that value to 68 or 82K, something like that. But right now it's currently a 47.5. I had to pick a value. Math-wise, it, you know, kind of worked out. Lederman, he's in the house. I just painted the chopper. Awesome. I know that I saw that you were grinding on the tank or whatnot, and then I saw that you were talking with him on the phone or something, but I'm still not done. I just got started. I literally just got home like freaking 20 minutes ago. I get no love, I tell you. But I did get a present. Christmas came early. Look what Daddy's got. So I'll put that in one of my amplifiers. I have a combo amp that I have earmarked for that. So Andy hit me up the other day. He's like, hey, you know, somebody's looking to get some speakers for their amp. Nudge, 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 nudge. You better go buy them all out. Well, they had 2 left, and the price on it was just too good to be true. I was like, nope, we're going to make it so they can only do a 1x12. So I picked one up right away. I probably should be spending my money on other things. Shh, don't tell the wife. 8 or 16. This one is a 16 ohm. I like the 16 ohms. Although I should have gotten the 8 ohm. I don't know why I didn't think about that, but this one is a 16 ohm. It is what it is. Was in the response. Okay, cool. So I already have a Celestion Gold. I have 2 Celestion Golds. I have a 12-inch and a 10-inch version. I have a 10-inch and an open back like cabinet that I have an oversized open back, and then I have the 12-inch in my 5-watt design, the one that AC really likes. It's just such a waste of a speaker in there. I mean, I think the Gold is like a 60-watt speaker or something like that, and it's in a 5-watt amp. So that's what this one's for. I think they sound pretty close to the same, so we'll see. All right, anyway, let's go through our process today. All right. Oh, knock it off, YouTube. So what I'm going to do is show you kind of how it is I just do my little startup check, right? So more or less, this is the last chance to kind of go through your schematic and see if what you did schematically matches what you did inside the amp, right? Makes sense? So you just kind of go through, do you have a grid leak for each of the tubes, right? So you need to have a grid leak of some sort for each one of the tubes. Now, in my case, I did not put any of these grid leaks in here. The volume pot is acting as that grid leak. I thought about adding these in there, but yeah, I don't think I'm going to need it. Now, you can add a grid leak over the top of the volume control if you need to. So that is an option that I may need to, we'll see. We may not need to, I don't know. But more or less, what I have done in this design, as you can possibly see, is that there's a volume control here, a volume control here, a volume control here, and another volume control there. A lot of volume controls. Now, what I didn't do was show how it actually lays out in the chassis here. This volume and this volume are on a dual pot. So I have a dual pot in here that you can see, and what it does is it circumvents these, these two, well, this stage. It's on each side of this stage here. So it allows me to reduce the gain into two stages simultaneously, so I can get more range out of the gain that I have on the amp. But you just also want to make sure that you've got your grid stopper values in there. You may or may not need grid stoppers, but things like that. Now, I'm going to tell you right now, if you're taking screenshots of this schematic right now, it will make noise, probably. But do not count on the values being correct. These are arbitrary values. As you can see, I put 220, 220, 220 for each and all of the grid stoppers, with the exception of this one over here, which, again, this is a high watt output section here. I did not change anything in here from the standard high watt. So if you look up a DR504 schematic, everything from about this point back is a DR504. The only other thing I did different was the bias circuit, which is noted here. And you can see how I kind of did it with the safety resistors and whatnot. If by any chance the wiper comes off of this thing, if it ever should, maybe the trace goes bad or the wiper breaks, whatever it might be, it still has 10K of resistance to ground, which means it can never go full open. It actually, in fact, it will go full negative. So it'll go to the lowest voltage that it can possibly do. Oh, nice and broken in. Yes. Yeah, no, they're pretty close, I think. Another free learning session. Yeah, so this is more about the startup process for a new amp, I guess. If you're building a guitar amp, this channel is more dedicated to the people that are trying to learn how to build a guitar amp, not so much do work on or repair to. Repair kind of has a different mentality altogether. But so in either case, you can see, I'm saying don't rely on the values here. You're going to have to do your own stuff. I will go back and update this for myself later on once I have an as-built actually done. Power section is generally pretty easy. I am very certain that my power section is good. I'm quite certain that I did things well in the bias section, with the exception of this guy right here. After kind of looking back at it again, I think I'm going to end up a little too high of a voltage. So the closer you are to ground here, the closer to ground your negative bias becomes. So if you need a larger negative bias, you actually increase that value there. So I think I'm going to need a 68 or an 82K. We'll find out. As far as the negative feedback and all that and stuff goes, that's all standard, high watt stuff. Now, layout wise, this is more or less what I did right here, right? So let me zoom kind of in and out there. You can kind of see when we go back to the other thing, this is what I did. I've kind of double checked this a few times. I did it once already with you guys the other day. I'm quite certain that everything is aligned the way that we need it to, but let's kind of just do that in real time and just make sure we haven't done anything crazy. We want to make sure our screen grid is attached to our screen grid node and stuff like that. We want to make sure that our grounds are all touching and stuff. So this is DIY Layout Creator here, this one here. It is finicky, it is fickle, it is free, and that is why it is all the above. Now, you must be careful where you get this from. If you get this software from anywhere but I think it's the GitHub page, be very wary. Try to find the actual link that comes from the guy that makes it, because there are versions of this out there that do have viruses in them. So also do a virus check on your version. It will put on some weird software that actually gets installed in your thing, and it's, I guess, a pretty aggressive form of it's not a keystroke, but it's looking for passwords in your laptop is what it's trying to do. So you don't want that. And then this other software here, this is DigiKey. So if you go to DigiKey, you can find some of their online stuff, tools that they have. It's kind of like a Trojan, but it's not. It's literally a software that it installs with the program. The program works fine itself, but then this other software just kind of rummages around your computer trying to get your passwords out to the rest of the world for them to do what they do with it. Schemit. So Schemit is a free software offered by DigiKey. And as far as things go, again, it's kind of finicky. It does its little thing, but it works really well for this kind of stuff. They have tubes, sockets, and all that fun stuff. But again, being free, as far as what you can do with it, it's pretty dang cool. So those are the two that I use just because. So yeah, let's just kind of go back over here and just kind of do some quick test-roonies. We're just going to go into beepy beepy mode here on our thing here. We just want to know that things are beeping like they should. So I just stick that in the ground and I'll try to show what I mean. So this should beep. That's a very important beep right there. You want your input to be beeping when there's no connection, right? And then you just kind of go around and make sure all your other grounds are beeping. Right? Beep, beep, beep. That's beeping. What else should possibly beep? This should beep over here. This is our bias circuit, right? That should better beep. Remainder of the bias circuit is beeping. None of these other parts should be beeping. That's good. So there's no shorts in that regard, right? Yeah, I still need to put the pilot light in there. Where this should beep. All right. So go through and just double check, make sure everything that's supposed to beep beeps. And everything so far is looking like it is. So all my cathodes are beeping. Yep. Cool. And then I guess if you really want to go crazy, you can just, actually measure out different values. But literally we're going to go through and just kind of just double check and make sure things are beeping that are supposed to. So this should beep over here, I believe. And it does. So we know that we should be able to get our screen voltage over there. And then of course, if we measure over the top of this, we should get like 1K or whatever. It's not in measurement mode, but if we put it in measurement mode, we should see about 1K. 995, 998, that's close enough to 1K for me. So you just kind of literally go through and do those sort of things. And then you can, if you really want, like literally trace out your circuit. Do I have something here? We got to be in beep mode for that to happen though. Yes. 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 Right. And then down in you can literally go the whole way, all the way through your circuitry to be sure. This is the center point here for our negative feedback. We got a beep there. We got a beep here. And we should get all the beep all the way over to here. One of these, I think, beeps. I can't remember. Or is it this other side? I think it's this other side. There it is. And then it comes back. That's ground right there. Or at least it should be. It is. And then I can't remember where this comes back in at exactly. It goes back in somewhere. It jumps over to this guy. Right? And then that guy jumps from there down to here. Right? So this is where it actually injects inside of the tube. Literally, no, the tubes are not in when you're doing this. Now, there's some other things you got to be mindful of. If you're doing some of these beepy beepy tests and the pot is all the way down, that is essentially putting it to ground, and I'll show you what I mean. So if you do something like this, helps if it's on. Is it that one? I can't remember which one it is. Maybe this one doesn't do it that way. Oh, that's not a grounded pot, duh. There it is, right? Center. You probably can't really hear that, but as I manipulate the pot, it will beep when I have it all the way grounded. That is a good thing. So that's one way you can test your pots to make sure that they are doing what they are supposed to do. Those are the things that I do. This will be an EL34 amp. We're going to run EL34s with it. So the tubes are not in here currently. So all those little things I have done. I have gone over the power supply section of this thing many a time, so I'm quite positive that's going to work. But the only thing I haven't put in here yet is, it's a real show, ladies and gentlemen. I need a lamp. I gotta remember where I put the lamp. I keep them in a thing somewhere, and I just don't remember exactly which one it is. So let me find the pilot lamp real quick. It's in one of my bins here. My apologies. Really? Which one is it in? Did I just like straight up miss it? Is that what it is? I know I have a whole bin of them. That's just it. I should have thought about that a little bit sooner, I guess. My apologies. Bear with me while I, work out some of my own logistics here. I have all my fuses, but I know that I got bulbs in one of these. I just can't remember which one I put the bulbs in. It might be that I moved them into another one of my things altogether. I know it's not in those. Well, shiza. Thought I put them in here, but I guess not. Let me look one more time. Holy hell. Well, now I'm just a jerk. So I have the pilot lamps and the jewels, but I didn't put the bulbs with the jewels. What is wrong with me? Sometimes you're an idiot. Sometimes you are. Sometimes you feel like one. Sometimes you are. All the above. Holy cow. Somewhere out there I have a thing full of jewels. Jewel lamps. And I got literally, I know I have them. I just bought like a brand new package of them. I wanted to use the LED one for this. You know it's not in this one. Well then. Tell you what, I'm not gonna fudge around anymore. We're gonna rob Peter to pay Paul. I literally have brand new boxes of them. I just don't know where I put the brand new boxes of them. Golly gee whiz. Alright, there we go. Now we've got a jewel lamp so we can actually see that this thing is turning on. Get in your home. I'm telling you, it's been one of those days, guys. It's been one of those weeks, really. It's been like that for the last couple weeks. Just like stupid busy for no real reason. Namaste. All right, power switch is in the up position. Well, in the down position, technically. In theory, I should be able to plug this thing in. And if I turn it on, I shouldn't get any smoke. I guess this is kind of the moment we've all been waiting for. I'm going to plug this thing in and... Well, there's other things. Let's check these. So we got the output section here. You definitely want to make sure that that's kicking along. I'm relatively positive that is all good. So there's not really a way to check that. We got the center tap coming off of that point there. So if I go into beep mode, I think it should beep for a second there. And that would be the case. So it probably wouldn't hurt at this time too, to take an ohms reading of each of your plates. So this side here is 39 essentially. And this side here is 43.8. They're never really exactly the same. Now, this isn't necessarily important because the way that we're setting up the bias on this amp isn't necessarily going to rely on those numbers. And I'm looking for a pen and a piece of paper right now is what I'm doing. But I will write this number down. It's just going to be for future reference later on. So we had 43.8. And then we had 39, I think it was. Is that what it was? Did it say 39? Pretty sure it was 39 something. 39.1, that'll work for me. So 39.1. All right, we'll come back to that number here in a bit. All right, we've got something. We know that we've got continuity there between our center taps and all that jazz. I'm done playing around. Good morning. Welcome, guys. All right, here we go. We're going to plug this thing in. That is plugged in, and what do you think is going to happen? Are we going to get smoke or what? I see a jewel lamp, and I don't have any smoke. Ooh, so it's on. The amp is on right now, just FYI. You can see the blue on my hand there. So right now, there are a bunch of angry pixies floating around inside of this amp, and nothing went sparky, sparky, boom, boom. That's a good thing. So now, we're really only worried about AC voltages right now. We only really need 2 AC voltages. We want to know that we're getting something on our HT line, and we want to know that we're getting a voltage for our heaters. Those are the only 2 AC things in the amp. So we're going to start, let's get in on this side here. What do we got? Oh, always go to the 600 volt range first, by the way. So, and it should be some high number. 303 on the dot there. Very good. That means our thermistor did its job. It is firing up. Now we should have a voltage on our bias rail. We want to make sure that we got at least something there. Exactly 50 volts. It is supposed to be 50 volts. That is good. And now we want to know that our heaters got something on them. So we should see 3.13 volts on this side. 3 volts. And then we should see 3 volts on the other side. So I'm going to get in over here. And again, 3 volts. Right? Yeah! Okay, so we know that we're working there. Now we want to know our DC voltages. So we're going to switch over to 600 volt DC. I don't know if you guys can see that. Yes, you could. Okay, good. Good. Now we're getting in over here on the angry part. So right here, if I touch in on that, I should get something like, ooh, 422. I was hoping for 424. The thermistor is probably eating a couple volts. It does require a couple volts. So 422, that's fine. Now we can find out what our bias voltage is actually going to be. I'm going to go here, and it will be a negative voltage. And you can see it's minus 2 volts. That is way too cold, or too hot, I should say. So let's just make sure that our bias pots even work at all. So I'm going to turn it all the way the other direction and see if it changes value. And I'm adjusting this pot here, so I'm going to measure at this pot here. And it went to 0 volts? No? Or is it above my thing is what it is? 4.8. So this is way off. We're going to have to go much, much higher. So let's see what our raw bias voltage is over here. So minus 16. That ain't going to cut it. So we got to go much, much larger on that there. So unfortunately, I was way wrong on that. I was shooting for about 20 volts to 40 volts. I got 20 volts down to 0 volts essentially. So that is no good. So we will need to change that. Short-lived on that one, right? Yeah, it's way too low there. Unfortunately, I don't think we're going to see much else, right? So we can go down I guess we can go down our HT line, right? So let's check our screens and make sure we got voltages on our screens, and it should be high. It's going to be high all the way across. So we had 423 there, 423 there, and it's probably going to be the same over here. 419, it actually did get a drop, which means on our next node here, it's probably not going to drop that much, if any. Knock it off. 414, it dropped another 4 or 5 volts, and then on our last node here, it should be even lower still. And it did. It dropped about another 4 or 5 volts. What size do you have right now? I have a 47.5K in there currently. So apparently I need to go up to maybe even possibly 100K. What do we got here? Okay. So that's a little bit of a bummer in that regard, but we do have voltages throughout the amp in the spots that we expect to see voltages inside of the amp. So I'm going to turn this off. Click. I can feel that there's heat coming from down underneath where that thermistor's at, so that means the thermistor is working. I'm gonna unplug the whatchamacallit here, and then I'm just gonna turn it back on to let it kind of do what it does. You're not going up. Pull it to 10K. I'm pretty sure I got to go larger in value on that to get more negative voltage, if I'm not mistaken. I had minus 50 on the one side. Well, okay, let's do this. Let's do this. So that's on. Yeah, that is on. So I had 50 volts raw on the one side. So now it's going to be, should be a DC-ish voltage on the other side. And it's going to be less than 600, so I'll start there. So on this side here, we should see, yeah, about 70 volts. That's right up. All right, 69.4, 69.5. So I should be able to get as much as 60 volts. But on the other side of this 47K, it's dropped down to 16 volts already. Now, I don't know if that's because this other side here is pulling it down with it. So let's do this. Let's just make them both turn that way. Let's just see what it does. Yeah, minus, I mean, it's like essentially nothing. Minus 17. So, pretty sure I got to go larger there. Raising bias cap size can drop a few volts. You think I need a 10K? Well, I'll give it a shot either way. Now, no. Lower resistor. Okay, I will try a lower resistor. I'm going to need this. I'm also going to need to turn on my iron. Excuse me. Looking for resistor. And I wonder if I just, we're not going to bother. I'm going to find a 10K. There's a 4.75. There's a 6.8. I need to mark these things out. There's my 10. I'm going to drop a 10K. I'll just literally punch it in over the top is what I'm going to do. I'm going to be a lazy dick and just put it in over the top. Because I don't really, I'm not that worried about it. Going a little bit hotter there. And if it fits, it fits. If it doesn't, it doesn't. Okay. So this is where it gets ugly. You're actually seeing like the ugly side of what goes on here. So just gonna tack it in literally. There you go. And we'll get a little bit more on this one. So this is how you burn through a dollar resistor. Quite literally. Okay. So we're going to try it again, and we should have a higher negative voltage. So we're already in the up position. Let's not do it wrong. We'll do it right. I'm going to come up out of the 20 volt range. All right, so we should have a higher negative number. Well, no, because you said to go lower, so now I'm sitting at more like 30-something K. So I better have a higher freaking voltage. And I do. I got minus 44.9, which is probably kind of ideal. Let's see what it is when I turn it down the other direction. I'm trying to get a range on it now. So if I go all the way down, it should be some lower number. Didn't really change much. Oh, because I'm measuring it on the wrong side. Sorry, we got to measure it over here. Frickin' thing. And it should not be 0 volts. 7.6. So I get a lot more range than I probably need, but I guess we can see if we're going to get right. So when the other one's all the way down, it pulls it with it. I don't know. I might need to use some other resistors there too. I might need to go away from the 10Ks. Unfortunately, I'm not getting enough bias range, which kind of sucks, but what is it when we actually get to the tube itself? Yeah, 11.9. That ain't gonna work. That ain't gonna bias out. Minus 100, no. I know I'm not gonna get minus 100. I got 50 volts solid on this side of it. On the other side, I had a solid 70 volts. So I know I can't get more than minus 70 on it. Minus 11.8. I might just be able to go, well, I can't go hard. You need to have a dropper there of some sort. I'm going to have to go with larger resistors, I think, on my, so those 10Ks that I put in, I'm going to have to go larger, I think, on those, which kind of sucks because that means we can't turn this thing on and make noise until we get that sorted, unfortunately. So that is a 10K right there. So I've got less than 10K. I have, I don't know, what does it add up to? Probably, it's under 20, I know that. It's more like, yeah, 5.85. Darn it, you can't even see. 6.98, 8.5. 8.5K is what I got right there. That's sounds about right with a 10K over the top of a 47. So wall volt will not matter too much, but yes, it will. Right now, I am getting exactly what I should be getting in the spots I should be getting, with the exception the bias circuit is pulling too much. So I put some 10K droppers over here. I probably need to go larger in that value, so it's not pulling so much down. So the downer is that I've got a 10K pot on each one of these, right? So I've got a 22K in line, and that sucks too because I might need to get rid of the 22Ks, but wait. So I showed you the freaking schematic. Do you guys not read? I'm kidding. I'm messing with you guys. So right here, this is exactly what is in the amp right now. Sans I got a 10K over that, which makes that an 8 point something K, 8.5. So if I take the 10K out or jump it, that's going to make my situation even worse because that's going to get me even closer to 0 volts. I need to hold these up higher is what I need to do. I'm not going to answer the phone. I know that I need to adjust this circuit. So there's two things I could do. So there's these 22Ks that we have in line here to isolate those. So obviously going smaller here did draw the negative voltage up. And then these 22Ks are to isolate these two from each other. But the 10K that I have is getting me too close to ground. And I don't think it's going to help me much to even put a 10K here. Realistically, I probably should have just... You can't find these pots in not 20K. So the only other option I have is to make these smaller, which makes these pots interact with each other a little bit more. Now, it may change a little bit once other tubes are in the circuit and it's actually drawing some stuff, but... Oh, yeah, that's right. There. That's exactly what I got. I've got minus 50, or I've got 50 volts right here on the dot. Exactly 50 volts on the dot right there. I put a 10K over the top right there, which leaves me with 8.5K or something like that. I have 69.8 volts on this side of the thing after it's rectified. You get full rectified. Well, yeah, I guess I could do that, but I don't think that 8K is going to buy me much more. Higher, yeah, so my tail resistors, which is these ones here, is that the one you were talking to? Well, I can't take the 47K out now. I have a 10K over the top of it, right? I have an 8.5K essentially right there. Now I could go with a like a 100 ohm or something. I don't think I need much. It's not that I need much there. But I don't think that's going to solve my problem. Maybe it will. I don't know. I'll go with a lower ohmage though. Because 10K is still quite a bit. I want those 22Ks there because I want to isolate the two pots from each other. There's a 3.3. We know that probably won't work. Here's a 680 ohm. Damn, beer's doing its work. Let's go with a 475 ohmer. So I'm going to put a 475 over the top so we get at least some sort of drop. Won't be much. But I want those nodes to actually do what they're supposed to be doing, which is isolating and decoupling a little bit. There's that one. Hold on. And then we got this one. Did you notice I'm touching that? Tells you how little I'm not worried about it. My bias is not fucked. I have bias voltage. It's just the 10K stuff that I got going over here is pulling it down more. So I either it's gonna work. It's just gotta do some adjusting. No fuckage going on here. Just gotta do some more mathing. The mathing has to get done more. That's all. I know you guys want to hear noise right now. I could have not done this with you live. I told you, this is the reality of doing this stuff. You can guess all you want, and sometimes you just guess wrong. So, all right, so that's going to be a little less than 470 ohms now. I have almost essentially a dead short right there by like 400 and something ohms. So right now I'm going to probably have closer to 66, 60 some odd volts there. All right. Oh, you can't see it now because I'm only on this other freaking screen here. All right. Let's see here. Can you see that? There it is. Now you can see it. There's 66 volts with a 400. It's about 400 ohms right there. So it's jumped over with a 400 ohm. So what do I get at my freaking node? I bet it's lower, minus 20. And that should be even lower than that still. Minus 10. All right. So we're getting closer. So those 22Ks that I have feeding each of the nodes, I now need to make smaller is what it is. So I'm going to have to, those 22Ks that I really nicely put in there are going to have to come out. Just take them out and put a jumper. Well, for now, that's what I'm going to do is put a jumper. But, did I turn it? Yeah, I did. All right. Stop yelling at me. All right, so I think you can kind of see a little bit more about what's going on here. Maybe you can. So see those red wires down there and those two resistors? Those are the two 22Ks that I was talking about. So those ones might just be too large now. So I need to reduce those. I still think it's partly the 10K, but I should still get most all of my voltage. Either that or I got to go larger with those. I don't know. I'm going to jump those is what I'm going to do. More or less, I'm just going to jump those. I kind of want to use some old wire, though. Let me find some old wire here. I just need something I can jump with for now. We're going to do this just for testing purposes and so we can make some freaking noise and shut you guys up. And if it works out that I don't need to use those resistors, it just sucks because I wanted to get a little more isolation on those, but whatever. I mean, it's not the end of the world. I could care less whether or not I actually have resistors there. As long as the bias circuit works, that's the only important part. So, yep, right in here. And we're gonna get this one. We're gonna do the same damn thing. There. And then click. Oh, come on. Sorry, I'm not on camera right now. I am stripping wires. It's literally all I'm doing is stripping a freaking wire. All right. this isn't as foolish as you think it is. The objective was to try to gain some separation on the nodes and have good stability. I know it's going to be stable anyway because I got a fuck ton of whatchamacallit. That's why I want to leave as much dropping resistor there as I can, because that large amount of dropping resistor there will help in stabilizing the circuit just a little bit more. So, and there's that. There's that. Turn around here, get this side. Okay, clean the tip. Well, I am taking him out. That's what doing this is. Gall, darn it. Just chill. No. Nobody's harmed in the making of this freaking amp build. No children were harmed. Motherfucker. Need a little more heat. Man, I need the longer one is what I want to. All right. Okay, there's that. Getting in there. Ta-da. All right, and then we're just going to tack it in over the top there. So this is what prototyping looks like, ladies and gentlemen. It's not pretty. All right, then this guy here, same. Click. And then we're going to just ticky tap over the top there. There. Bias circuit is pretty much wide fucking open now. It should have like, I don't know. There's still a 10K dropper. I think the 10K dropper is really what's hurting me more than anything. But since we can get damn near full 70 volts of whatchamacallit there, that'll help make it so we maintain that. But that puts a lot of stress on the pots is what it is. That's what I was trying to avoid too, is keeping the pots from being too abused. Okay. There's that. There's that. There's this. There's that. No fire. All right. So what do we got? I'm going to shoot 200 volts. We should get something over minus 51. That is more than enough. I believe, hold on, let's see what happens now. So now it's going to be too freaking cold. I'm going to take the other one down and see if it adjusts. So they do interact now. But now minus 53 is too freaking cold, right? So we've gone the other way now. You see what I'm saying? So I know that those aren't going to be... It's going to be probably, instead of 22K, it's probably going to need to be like 10K is really what it needs to be. So minus 50 is going to be too cold. So we've gone the other way. You are not a pro, see? I knew I was going to need isolation. So that's still up. We're going to turn that off. So those hard wires are going to come out now is what we're going to do. And then what I'm going to do is replace it with, I'll put some 10Ks over it. I'll do something like that anyway. We're going to burn through some freaking resistors. I don't know if I have any cheapos. Let me see if I got some cheapies. See if I can bust out some. It's a 470. Don't need that much. 2 meg. There's some 100K. There's a 680. 6.8K. That might work. 1.5. 6.8 meg. 6.8 meg. That'll do it. 3 meg. 1 meg. 4.7 meg. 220. I'm just looking for a slightly lower value is all. I got some 10Ks in this value, but I don't want those. Although those would work too. It looks like we're going with 6.8K because not doing 820, not doing 680, not doing 10. Yep, okay, cool. We found what we're going to use as opposed to the straight wires. We're going to use a couple of these 6.8Ks. No, I'm not grounding the pot direct. You don't understand, see? It's got safety circuits built into it. So I can't rewire it, to be honest, because of the way the safety circuit is dialed in on it. Click. There is a method to the madness, my man. There is a method to the madness. And some things can't be changed because of it. So, all we're going to do is circumvent. So it's not even going to be 6.8K anymore. Is that going to be long enough? Yes, it will. It'll be something more like, I don't know. It'll be less than 6.8K. That's all I know. Come on. I'm going to burn my finger there. There we go. And I want a little more. So this should, what we're doing right now should get me somewhere in the middle of where we were just the last couple times. So just FYI. There we are. So now we have an effective resistance of whatever 6.8K in parallel with 22K is. It's less than 6.8K. That's all you need to know. Yeah, it's probably closer to like 5 or something like that. Okay, there's that. There's that. We're shooting for right around 40 volts. That's what I'm shooting for, is right around 40 volts. Somewhere in that range. If I can get between 35 and 40, I'd be happy. Okay. So there's that. And I guess I could use the... Oh, no, I can't use the friggin... Whatever. Let's see here. What do we have on our actual grid now? Did I turn it on? Got to turn it on. That'll usually help. 35.6. Calling it good. That's what I wanted. All right, so we'll have to make some edits to the circuitry over here, but we can, at least at this point, put some tubes in there and get some noise out of it. There you have it, son. All right, so we are now at a point where we can put some preamp tubes in it and check and make sure that we got preamp tube stuff going on. So I'm going to go ahead and turn off the iron, and we may or may not need that guy. Probably not going to need that guy. At this point, we know things are going to work. There we go. We worked out our first problem. Everybody together. We only had to curse at each other a little bit. Well, yeah, but it's got a little bit of protection built in. That's it. That's it. It's just a little bit of protection. It can never go full negative. And that's all there is to it. Or never, it can never go to full positive, excuse me. And not even positive. It can never go to 0 volts. It will always revert down to its lowest possible voltage. That's what will happen. So if the pot fails, it will always revert to the lowest possible voltage that it has, as opposed to shorting itself out to 0 volts. So if it goes to 0 volts, the tubes instantly burn up and cook and fry. We don't want that. Give me fuel, give me fire, give me that which I desire. We don't want none of that crap. Now I need to find where I put those tubes at. I think they're over here. Yes, they are. Had a whole stash of them. Oh, joy, everybody. We're finally getting to bust these things out of their rubber bands. All right. These are all the same. They're all JJ's. I don't want to hear another freaking word. All right. So I think it might just be easier to take this thing out. So let me do something real quick to make it easier. I don't really want to move this thing around too much more than I need to, but what I can tell you is that this thing is heavy enough and awkward enough that it's just easier to not. It's just easier to not. There we are. Ugh, there it is, top side. Okay, and I took one tube out already, but all right. Get this guy, we'll go here. What do we got? What do we got? Back, yeah, right? Boo! What do you mean, boo? What do you mean, boo, Riley? Damn, that was a freaking tight freaking socket there. She ain't going nowhere. Oh, boo is in boo and JJ's. I know you guys and your freaking Mullard fans over here. They're not even real freaking Mullards anymore. It's a crock of shit. It's a crock of damn shit, man. Part of me doesn't even want to worry about flipping it over onto that thing anymore. I know I'm going to need to just churn it over right now. Right now, at the voltage that I have negative-wise, I think it was, what, minus 35? I think that'll be damn near spot on, but we won't know until it's actually running. So, at this point, we're really only looking to see that we have a voltage drop. My cheap ass, it has nothing to do with cheap anything. Not a goddamn thing about it. Come on, baby. This thing's a freaking beast. Alright. Let's see if I can not bang this thing while it goes in. Trying to be nice and not bang it up before we hand it off, right? That's what we're trying to do. All right, so what we're trying to do now is just prove that the preamp tubes they're more than $12 now. Conducting. That's all we're trying to do right now is prove that they're conducting. So we don't actually need a speaker load in yet. So I'm going to turn this on and we're going to see if any smoke comes out and if we have glowing glass. I think we do. Yeah, I got that. I do see some orange lights in there. Orange lights are good. So what we should see is a slightly lower voltage over here than what we had before. And if you recall, it was like 411 or 410 or something like that. All right, so I'm just gonna go straight to here. And can you see that now? You can. And it should just be a lower number. It's obviously lower than 400, right? So we know that our preamp tubes are conducting. We are done there. I guess what I should do now is just go straight for the most negative voltage that we can possibly get on our power tubes. So I'm going to just go ahead and do that real quick. So I'm just going for as negative as we can get it. Those are already turned pretty much all the way up, except for that one wasn't. So we should be minus 36. Let's see what happens when we turn this thing, if it gives us anything different, where our range is kind of at here. So minus 36 is as low as it'll get us. I think that'll be right in our range of workability. I think it'll work is what I'm getting at. It might bias out, it might not, I don't know. It'll be close. We're still probably going to have to do some adjusting on this. Those 6.8s might still be a little on the big side. But look, the owner can do whatever the hell they want with this thing. But I guarantee you, it's going to make some noise and it's going to sound good doing it. JJ's or not, it's going to make noise and it's going to sound good doing it. If everything freaking works right now. I don't hear any hum out of the transformer, but I don't know if that means anything or not. All right. Rotate in, please. There we go. What are we banking on, everybody? Noise or no noise? Smoke or no smoke? The hope is that the tubes aren't biased too hot. 35, 36 is like right on the freaking... Ooh, don't you do that, is what we don't want. Apparently I put a little too much oomph in it. There, it's all the way in there. Okay. So now when we turn this amp on, we are going to have noise. So we want to make sure we have a speaker load. So we got a speaker load. I got it on the right ohms tap. We've already got the lowest voltage we can get on the whatchamacallit. So I want to turn it on and hopefully we just get noise. With any luck, I don't get shocked to death either. We'll find out. Okay, we're in there. Okay, here's this. And there's that. Fucking thing, whatever. Try not to get it so it touches any metal. Fucking hell, dude. Never mind, I give up. There. Alright, that's that. Master volume is currently all the way down. I'm just gonna crack it a little bit, and I'm gonna crack the other two volumes a little bit so it's got at least a chance of noise. On she goes. Oh, one plug away. Missed it by that much. Okay. I see orange. Did we do good work? Did we do good work? I'm not getting shocked, so that's a good sign. But I'm also not hearing anything. Could be that I need more oomph. Nothing. No dice, man. No. So that means we've either missed something or we missed something. I don't know what we might have missed. I'm looking here. I don't see anything else that would have been bad. Oh. Oh, wait. I know what I did bad. I'm an asshole. We're going to need a different... I've never seen that before because I always wire the pots this direction. Or the whatchamacallit's this direction. Is that right? Yeah, no, that's right, actually. Hold on. Yeah, that's correct. Never mind. We are okay there. So that is fine. Sorry, I'm just looking around here to see where we might have missed something. Because we should have noise. I guess one way we can find out. Nothing went up in smoke, so... probably don't need that much master volume. I'm kind of feeling like I might have missed a wire. Like, we got no hum, so that's... right? There is no hum, so that's a good sign. That's good there. So this should, yeah, that's, it's getting signal from that point right there. So this thing is on. So let's touch probe on in there and see if we got something. But without any, there's like zero noise though. So like not even a hiss on the speakers at the moment. So something is either terribly wrong or terribly wrong. Well, that doesn't do anything. So if I go to the grids, oh, there's that. So I got minus 36 volts. Yeah. Wow, this thing's like dead silent. I'm right at minus 35. So that's working there. What am I missing then? Let's see here. Going into the phase inverter. Did I miss something going into the phase inverter then? Yeah, no, there is noise. There is no hum. I mean, I can't even tell that the amp is on right now. It's so freaking quiet. Until I touch something. But the master volume does nothing. So the master volume, like, there's nothing coming in. So either this is bad, which is kind of what I'm leaning to right now, is our signal coming in. But I'm trying to see here. So this is our anode, right? Yeah. Did I miss one? That's our cathode. The cathode goes in. So that's our plate. We got 350 volts on our plate. So we're not getting any signal. So I did something wrong in the pi area, apparently. It's kind of a bummer. So the output section's fine. I have never heard an amp that clean before. Like, there's zero freaking hiss whatsoever. But then again, it's not making a whole hell of a lot of noise otherwise, though, either. The input is working correct. We just can't hear it because there's nothing getting into the pi at this moment in time. So, where did we go wrong? Where did we go wrong? So, let's go back the other way here. 2 wires on master volume. Well, there's 3 technically because this one goes in. You just can't see the ground because it's kind of underneath your vantage point there. Damn is correct. So we got noise coming from the output. We got noise all the way up to our plates. So when we touch the plates, we got noise there. So that's working like it's supposed to. I just got to go through the circuit and see. Yeah, no, there it is right there. See it? That's the ground there, but this just happens to ride over it. The vantage point kind of sucks for you guys. So somewhere in the pi section is where I biffed it, because I'm pretty positive that everything beeps out correct. So either the schematic I got for the output section was bad, or I just straight up missed, like, there's like an air gap in here somewhere. But based on what I can tell, I think I got it right. So let's kind of confirm a couple of things here so we can go back. I can confirm that what is on, you can't see it yet, if you wouldn't mind, thank you. What you see in here is what I've done in the amp itself. So let's kind of just go through and troubleshoot together what that is. So this jumper right here was the one I was always kind of wondering about. And it goes to this 1 meg, right? So this is the grid. That's the anode. That's the grid. That is the cathode. Hooked preamp in. Right now, I don't even have hum. Like, it is so quiet. There's not even any hum. But, so, I'm not very familiar with high watts, so I don't know exactly how they kind of work in that regard, but this is the spot right here where things kind of break apart, I believe. So I'm going to kind of go through and show you what it is I'm doing. I'm going to try to do some beepy beepy and unplug some stuff here too. But we know that the power section is making noise. Yay. A couple little problems. That's a bummer. I was hoping we'd at least get some ugly ass noise. So we got beep mode on from my cathode to my grid. I got a beep. So from here to there, I got a beep. And then this wire. Oh, wait. Is that what I did wrong? I think that's what I did. I think I'm actually just straight up missing. I am straight up missing an entire wire. Okay, so see this wire right here? That one? I am missing that wire. That is what has happened. So there's 100K here. So there was no grid reference for the pi, and because there's no grid reference, that means it does not work. Well, at least we found where my air gap was. Remember what I was talking about? How you're supposed to go through and like do beepy beepy and, you know, actually confirm all this kind of crap? That is why. Because now I got to freaking come up with another wire that I got to get down in there. And that's it's gonna work. We're gonna do this, but oops. So yeah, imagine that. So without a grid reference, a grid leak for the pi, it will not conduct on the input side. So that's why it doesn't work. Makes sense? I hope that makes sense to everyone, because it sure as hell makes sense to me. I'm going to cut it right freaking there. So I should have actually just beeped all the way literally through the entirety of the circuit, apparently. and I did not. And you see now what happens when you don't do that. Let's get that going. So if you don't actually beep all the way through your circuit and actually check everything, guess what happens? You end up with an air gap like I did. So I'm not worried about that. God damn it. I'm more worried about is getting the freaking thing to come off. I don't worry about discharging the caps. If you're that worried, I left it on. Just to give you an idea, I don't use any bleed stuff or whatever. Let's just see kind of what's sitting in here. I'm sure there's voltage. I know I guarantee you there's some voltage in there, but how much I couldn't tell you. It's 19 volts. There, 19 volts. What do we got here? 19 volts. So it naturally discharges pretty quick. So that's why I never really worry about it. And then as soon as you touch this guy in there, it'll discharge whatever's left, if there is any left. So I don't really worry about it that much. Now, it's a different story when the amp is on. Obviously, I'm a lot more careful when the amp is on because, you know. But it's controlled chaos. That's what I call it. I've always hated that idea of telling everybody, there's deadly voltages in there, you're going to kill yourself. It's like fear-mongering. Now, don't get me wrong. You can get hurt, especially if you do something dumb. But for the most part, there's really not. Just be smart. Just be freaking smart. You've got nothing to worry about. That's all you got to do. So, I don't know. That's just me, but I'm going to go with a little more heat, though. And then I'm going to get in on this side here. Come on, baby. Melt. There it goes. Okay, so now we're going to get this one. I think I want to go this way with it. Yeah, that's what we're going to do, is go this way with it. Okay. Then I'm going to get in on this. I'm going to try to get in on this side here without touching my freaking cap. That was good to begin with, but there it is. All right. I don't need 7 plus 100 volts anymore. I'm going to go there. All right, what do we got? Who's talking? You don't want to discharge yourself out of this world. Nah. It'll just hurt for a second. It's fear-mongering. Now, I'm not saying go in there and just freaking touch things, but I'll bet it's even lower now than it was when we first checked it. So, that's what was it sitting at now? Oh, it actually grew a little bit. Oh, darn. We went from 19 volts to 21 volts. It's fine. You won't hurt yourself. I want to figure out how I'm going to fold this in there, though. So how am I going to do that? I got to pick a spot to, like, do this. So I'm going to say right here. And then give it just a eek more. All right, there's that. And then I want this. We're going to go up. And then we're going to go, yeah, right there is good. Now, I'm not saying don't be careful. Don't get me wrong. I'm not saying just start dipping your toes in the water or something like that. But, I mean, yes, there are dangerous voltages in there. It's more when the amp is on that you got to worry. So, the initial zap that you're going to get is going to be, it's going to discharge about 60% of whatever the cap has stored in it. Thereabouts anyway, about 60%. So you'll get zapped again if you really goof it up, but darn it, I want that thing to bend out just a little bit more. There it is. I think. Did you go in the hole? Yes, you did. Yes, you did. But I can do better. I can do better. And I will do better. I'm going to get this thing to bend just a skosh more. There it is. I want it to poke out the other side of the thing there a little bit more. There it is. So I got the fun joy of getting my gun down in there without melting or hurting anything else. There it is. Okay. Now, hopefully, this actually fixes our problem. The funny thing is, it might not. I don't know. There might be another. If I missed one, why wouldn't I miss another, right? Okay. Okay, there's that. That looks like a good weld to me. Let's see if we have a different result. I think that was the air gap that I was looking for. I think. But we won't actually know until we get more noise. All right, where are we? Click. Let's get this back in here again. Let's make the master volume, just cracked it a little bit. We're going to turn our volumes down a bit so we don't freaking kill ourselves, because that would suck. Now we should actually possibly get some freaking serial action. Off position. All right, what do we got now, do you think? Just kidding. I live on the San Andreas. That is correct. I live in the danger zone, baby. Let's see if we have a different result, though. So, still don't hear any noise yet. Also not getting shocked. So we still didn't fix our problem. Yeah, we still got that. All right, so we got something else going on still. What might that be? I don't know. I don't know. So we should get a bop if we hit this one. No? We also don't have any voltage. Well then, where are we missing signal at? It seems to be on the input side. So did I really just fork it up? Oh. No, that's right. That's right. Okay. Oh, I missed another wire. There's 2 wires I freaking missed. Holy hell. How did I miss those? I don't know what the hell's wrong with me. So, no cathode. There's no cathode either. Oh my god! Oh my god! I'm laughing because it just goes to show how freaking tired I was the last couple weeks doing this thing. Like, straight up missed 2 wires in a row on the last freaking tube. And I started over here and went this way, right? So I'll show you the wire that I missed. What is this right there? It's a 22K. 22K is the cathode to what? This white wire right here crosses over to the cathode of my freaking phase inverter. With no cathode, it's also not going to function. Oh my god. Again, driving home the whole concept of, thou shalt freaking trace out your circuit. Is it landing now? Even I'm kind of guilty. I sort of kind of went through it with you. Obviously half-assed. Certainly not all the way. Golly. Well, as they say, if it were easy, everybody... Goes to show, though, that at least my circuit and schematic are right. So, that was a good thing. So it's just, this one was just straight up builder retardedness. It happens. It happens to the best of us. I did it on purpose. I'm kidding. I didn't do it on purpose. But it sure would have been cool if I did. Make you guys wonder for a minute. We're gonna have noise tonight, everybody. We are gonna make noise. Again, we're kind of getting to that point where I wonder if the freaking preamp's gonna work too. What did I miss there? Who knows? I don't know. I will not fault myself for the bias circuit though. That is one of those things that's, I just made it up. Like, I had to come up with some values. I did a little bit of math on it, and obviously the math didn't pan out in that regard. But you don't really know until you just don't know. You just don't know. Okay, so we're gonna get this here. Actually, I'm gonna get on this side. Come on, baby, heat up. Oh, I guess it would help if I had the heat to do it. There it is. What do you know? Right away, too. Just fucking... Boop. There it is. All right. And this one, I'm going to go on the inside of it. And we're going to get some hot pie action up in here. All right. I want that to cool down, because I do want to add a little bit more. But what I like to do is so I get it to stick, and then I get the iron on the back side so it melts again, and then I add it on the front side so it pulls it back. That makes sense? I want it to pull the solder to the back of the joint. So the solder will generally, and you can see I was touching things in there. I did not get shocked. Generally, it will follow the heat. The solder will flow towards the heat. All right, so Andy, do you think we're gonna get noise now that the freaking cathode's in there? Come on, you guys, you're supposed to freaking help a brother out and freaking get it so I don't fudge this kind of stuff up. So I blame it on you, kind of partly, not entirely. You guys are supposed to check my work with me. I shouldn't be the only one that makes the mistakes here. Teasing. Totally my fault. I make mistakes too. Not very often, but I do make mistakes. And I want that much. Come on, baby. Alright. This might still be a little on the long side. I don't know. We'll find out. I'm going to get this thing kind of done up, though. Let's see here. I gotta stick it in a thing that's kind of buried down there at the moment, though. So I'm gonna work my magic here and try to make it open up there it is. I don't know what I did, but it opened up a pocket for me. Now, will this fit in that hole? I need my other manipulation tool. Thank you guys for hanging out with me too, by the way. I don't have my metrics up, but let's see what we got here. There's 14 of you watching me freaking duff it. I'm telling you right now, it happens. Most of the time, they just fire right up, but you know, this one, obviously, I kind of want to go shorter. Yeah, we're redoing that one. That is not to my standard. So we're gonna go shorter. When I got enough, I can pretty much take it to, I think, there. I'm gonna go to there. And we're gonna do this again. I'm gonna get that a little on the, there we go. Okay. All right. I know what my problem is. Freaking huffing goddamn freaking soldering fumes for the last week. Oh yeah, that's much more better. I am so much more happy with that. There it is. Now I just want it to stay in there. And then we're gonna get down in there, get down on it, down, down, down. And not burn all my other wires. Come on. Ow. Yeah, a little bit of touchy action there. Didn't like. but we're gonna be okay. It did not hurt the wire. This Teflex stuff is something else, man. All right, now I'm a little more confident that we'll get noise after what we've currently been through. A little more confident. How many other things did I freaking do wrong? Let's actually confirm this connection. And yeah, freaking hell. Come on now. Yeah, okay, we got something. Okay. This is for all the tea in China now, I guess. I don't know. It saved me 4,500 building classes. You're right. It's just slow and steady wins the race, really. When you start trying to hurry and obviously you cut some steps out like I did, that's where mistakes get made. And, you know, you miss a couple wires. I see something on every freaking one now. It should have been, it was like glaring me right in the face that there were, you know, no wires attached to those grids or whatever, you know, pins or whatnot. So you would think that, duh, right? Something should be there. Maybe. Mistakes were made. Kidding. I do have light. Still no sound though. Oh. There's sound. Not a whole lot. So we still have something else going on somewhere, but we do have noise. So we're not completely out of the woods, but there is some at least noise in this thing. I don't know why it's so low. Could be that it's just biased too quiet. We do have some blocking distortion. But we should have a lot more noise than that. So our present circuit does work. It sounds like our bass control works. There is no buzz. So there's something I think wrong in this. All right, let's we got like instant distortion like all the time now. So I cannot get a clean tone out of it at volume. The volume's all the way up and there's obviously like there's not enough gain. We're not getting a drive to somewhere. So there's something going on either in the preamp side of things over here or on this half going that way. Now, something that's always kind of bothered me was, let's go ahead and turn this off. That was interesting. That's a sound I haven't heard before. Let's see what that was all about. I want that to do that again. That's the kind of level that we're supposed to have. That's an interesting one. So when you turn it off, I hear a buzz inside of the amp. And that's with the freaking... Let's turn those down and see if it does it again. Let's turn that down. That is interesting. I don't know what that is. We obviously got more work to do. And there's no tubes are burning. Everything looks good. I gotta go through and suss some things out. There's something going on somewhere. Either I got bad intel on this phase inverter. I'll probably try disconnecting like the signal going into it to see if it's something there. If it's something, otherwise. Now, another thing that might be possibly causing some issue is I wired it like they show in the, what would you call it? I'll just show you. Let's do some reconnaissance here. Let me get kind of called up here. All right, so right here. Boop. Go ahead and unplug that. Okay. Yeah, Chrome PDF better shut the fuck up. Okay, so let's go to display capture. All right, so we're looking at this here. This is from Mr. Mark Huss's page. Yeah, right. This is Artemis 2 toilet. I've never had an amp buzz when turning it off like that, so I gotta look into it a little bit more. Obviously, we got a problem. Houston, we have a problem. So forget about everything from this point forward, okay? So everything here, this direction, doesn't exist. I went from this master volume, this direction, okay? That is confirmed. All right, so I wired it like you see it right here. So I put in a master volume with the 22K. I'll kind of show you what's going on here. Let me clear out some space here. Slightly embarrassing what we got going on here, but at the same time, this is, like I say, do not just take whatever you build from the internet or see from the internet and build it, because that is not a guarantee that it will work. And I'm sitting down now, so I need to move my camera. So give me a second while I do that. You want to go connect already, you freaking pile. There it goes. And I want preset 1. Thank you. All right, sorry about that. All right, over in here. Confirmed circuit, apparently. I got 100K, but see how it is powered from the first node here? I did that. Now, I grounded this node from this first power node as well. I don't know if that's what's causing a problem or not. I don't know. I don't think it would, because it's got the same number of stuff in between it and that point in the amp. So it's possible that I just need to power it from a different node, but I don't know. You built it 20 times. Okay. I'll call you in a little bit. Let me kind of go through what we've done here. What you see here is exactly what I've done. And I can show you. I did a 10K, 470, 10 in, 2 ground. And that is, down in the amp. I have the 100 in going across the 100K pot, and the present circuit does work. It injects itself into the thing via a 1 meg and a 22, and we can see that with how I did it here. So this is the NFB here, jumps across. That is our 22K. Send Andy. Well, I don't know how to do that yet. I gotta learn how to do that invite stuff. You'll fix it in 10 seconds. I'll call you. Hold on. What does he say? Get ready for... Oh, my buddy had a bottle for me. It's not time to celebrate yet, apparently. All right, so we're calling Andy Lederman now. He's on the phone. I'm calling you now, Andy.
All right, motherfucker.
All right.
All right.
Calling you now, Andy.
You're going to have to turn that off.
Yeah. Okay. Listen, man.
Okay.
Your B plus rail coming off. Your B plus rail for your phase inverters has to be full voltage.
Okay.
All right. So that means you're coming off of your screen node.
Yep, right here.
A 1K resistor, right?
Well, I got.
You're going to be So that phase inverter is set. Mm-hmm. I'm not joking. I don't know if you compensated for this, but that phase inverter is set for fucking 550 volts, dude.
Okay.
You only have 350 volts, dude.
Something like that, yeah.
Off that node. That's not enough, dude. That is not enough for that phase inverter, right? So you don't even have enough volts, to be honest with you, to power that phase inverter properly.
So right here I have a 6.8K. So you're saying I should drop that to like a 1?
No. So listen to me.
Okay.
So high watt comes out of rectification, and they get about 500. Their partridge is a 375, right, to 0. They come out of rectification right around 540 volts, right? And that B plus rail goes across the 100 ohm resistor, right? And it's not very much drop there. It's still
No.
540. But by the time you load your tubes down, the 100 watts of tubes, the 4 EL34s, and you get all the 12 AX7s in there, you sit right around 507 volts, right?
Okay.
That's coming off your B plus rail going into. Now, if you look at that schematic real fast.
Okay.
You see where it has a 22K?
Right here?
Resistor?
Or this one here?
In the high watt.
That one there, yeah.
Look at the top.
Yeah.
Look at the very top of it. You see the 22K?
Uh-huh.
That's because it has 507 volts there. Right?
Yeah, okay.
And you're nailing the shit out of those plates.
Yeah.
But 507 volts goes directly. Look at it. Look at the phase inverter. 507 volts goes directly into the plates of the phase inverter.
Okay.
Right? And between the fixed bias, it pushes those fuckers hard, man.
Yeah.
Real fucking hard. Real hard, right? I don't think that you're pushing those tubes hard enough.
Well, we know that it makes noise when you turn it off.
What? Oh, okay, so look at one of the things about when you turn it off, that is so my amp had that problem too, and that's a ground issue. So what that's doing is a couple of my amps did that before in the past, but it's just decharging and you can hear it. Sometimes they squeal at you. They're like space alien shit. That could be because you're out of phase, man.
It could be, but then again, I can turn the master volume all the way up, which does work. All admittedly very little, but and then the presence control I can turn all the way down and all the way up, and it does work. It is functional. But yeah,
I don't think that your phase inverter is bad, dude. I think you're not pushing the voltage. So what you need to do is put maximum voltage. So your first node, your very first node going, where you put your standby switch, go direct. That's where you need to go for the plates, man. You have to. You can't drop. Okay. You can't drop, bro. You can't drop. If you dropped, and I know you dropped, you run fucking B plus nodes all over that amp.
So this is what I did here. So I have a 200 it's not even a 220, it's a 200 ohm, and then a 6.8K.
I'm looking. Hold on, let me blow up the screen, the full fucking screen, motherfucker. Okay, let me blow in. So, hold on. Fucking Zoom. It's such a pain.
Are you not at the computer right now?
No, fuck no. I'm on my fucking stupid phone, and then I get fucking goddamn ads, right? Hold on. I turned this fucking phone. God damn it, Luke.
Here, hold on. I'll make it easier for you. I'll make it easier.
Computer, dude.
Hold on. I'll make it easier for you to see. Look, everybody.
It's all blurry now for me.
Oh, what? It looks clean as day for me.
God damn it, I can't even still see it. I'm blind and I'm old. Here, just give me fucking 10 seconds. I'm at my computer. All right, here. Internet. Fucking YouTube, motherfucker.
Okay, so to lead everybody in on what's going on the original high watt schematic, they use 100 ohm here. I went with a 200 ohm.
All right, wait a second. So look, Luke. Okay, hold on a second. So off of your A.
Mm-hmm. That goes to my center tap of the output transformer.
200 ohm, so you need to come off B directly into your phase inverter.
Okay. So they want it at the same voltage as the screen, pretty much.
Yes, they want it as high as. Look, and that's still awful low because you're only sitting at what, 420?
Mm-hmm.
Right?
Yeah, about 420.
Remember,
yeah.
But remember, so keep that circuit up there. Go back there.
Oh, I see. Yeah, they did. They come straight off of the freaking HT there, huh?
Yeah, right. Look at look at coming off of HT, you go across the 100 ohm, right? Then HT2, go to HT2 on your preamp.
Right here.
No. HT2 off your preamp of the high watt.
Okay.
No, the high watt. Go to the high watt schematic.
Oh, sorry. Okay. So come off of that.
It would come off your B node.
Yeah.
Yeah. So no, not that one. The other one.
Well.
Go to your preamp circuit of the high watt for the phase inverter.
Okay. So that's this one.
No, you're the fucking there you go. Go up. All right, now zoom that in a little bit here.
There, just did.
All right, now look at your plates. HT2, see it? See HT2?
Well,
directly
3.
in through an 82 and a 91K.
Yeah.
HT3. Is that what it says?
Yeah.
HT3?
Yeah.
Yeah, now go back to your power schematic.
My power schematic?
No, the high watt one.
Okay. That one.
And this is very important. No, not that one. The high watt one, yeah.
Yeah, this is the high watt one, yeah.
All right. Now look at HT3. It goes across, look what I said. So look, you come across that 100 ohm resistor. You drop that motherfucker across a 1K resistor, which is no drop at all, to be honest with you.
Yeah.
And then it goes right to H3. Now look, I want you to go back to the main page of Mark Huss.
Okay.
And then I want you to go to do it yourself. Down at the very bottom, very bottom.
Okay.
Go down to the very bottom. No, the very bottom.
I'm at the very bottom.
Bottom of the page. Bottom of the page.
I'm at the bottom.
See where it says tech page? Main high watt page. Click it.
Okay.
Main high watt page.
Okay. The DIY do it yourself page?
Yeah, go there. Yeah.
Okay. Heat shield, yada yada yada. Transformers, work in progress.
All right, now go down and look at the voltages.
Okay. So we've got 149 for V1.
Yeah, so look at your plate. 649 volts, dude. Look at your plate. 640. Pin number 3. Look at tube. No, look at.
Well, that's for
KT88s. Look at down there on pin number 3. You have how much voltage?
650 volts.
Yeah, they're pushing 650 volts into that fucking phase inverter, dude. Directly right into it, man. They're fucking smoking those phase inverters, man.
Yeah. Okay.
Right, and so I'm at 419 volts, so you should be able to get away with taking that node off of that B, because you're going to be reducing the wattage of that fucking phase inverter drastically because of that, how it's fixed.
Yeah.
Right?
Okay.
I don't think that's your problem, to be honest with you, but I do believe that it's severely under. You're not going to be getting pure power out of that phase inverter, right? So remember, the less voltage, the more that phase inverter is going to break up, and the less power it's going to put out. Yeah. I don't think that's the problem. I think you're attenuated somewhere down the line.
Yeah, there's got to be a problem elsewhere, I think.
Instead of taking... Now, another thing I wanted to ask you is go back to the main schematic. Okay. The main preamp schematic. Okay. And I've done this before, and I've done this many times when I build a high watt, and it's annoying as fuck. The preamp one. Now, I want you to look at the cathode. You see the 22 and the 2.2K? Yeah. make sure they're right, dude. Because I put a fucking 22K in the wrong spot there before,
Mm-hmm.
and I got no sound.
Yeah. Well, I can confirm that because that's one of the wires that I missed, and I see a 22K and a
Right, but if you have
2.2.
them backwards, it's not going to work, dude.
Yeah. No, they're definitely in the right order.
And another place off your master.
Mm-hmm.
Oh, dude, you're not even in the right one, dude. Fuck, dude. Okay, going off your treble. You see your treble to your master. Make sure that's not a 2.2K there too.
No, so I have it. So right here is where
orange. It's a red or
yeah. No, that one's for sure a
orange.
22.1K. It's 22.
Oh, you don't have.
Yeah.
Yeah, you don't have the colors.
Mm-hmm.
So I don't believe other than your voltages.
Mm-hmm.
Look, other than your voltages being super low on that phase inverter.
Mm-hmm.
I don't think that the problem lies with the phase inverter because this schematic is a known schematic. I've used it like 20 times.
Okay.
And it's worked every time. Now, I don't think you have so going from your cathode, do you have your 1M connecting? Do you see? So look at
This one?
go to your no other side. So look at it gets kind of confusing because look, you have a 1M to a 560K to ground.
Okay.
Right? And if you look, that 1M connects to the 100K, right?
Yeah.
22. So it's parallel. The 1M is parallel with your 22, 0.022.
Uh-huh. Yep.
But the 1M still connects to the 100K. Now look at your other 1M over on your phase inverter.
Yeah.
What does it connect to?
2 and 7. Your
Right,
your
but
grids.
It does not connect to your cathode. But it
No.
does connect to that 100K cathode follower.
Yes.
Right?
Yes.
Right? So what I did is when I was doing my layout, I got the 100K on the recovery tube and the 1M mixed up with the 1M and the 100K on the fucking phase inverter.
Oh shit! Wait.
Because I relayed it out, and they're both the same, and it looks the same, and I was like, "What?" the fuck, you know?
I'm an idiot. I know what my problem is. As soon as you said that, I'm looking at the thing going, wait a minute. I have the freaking whatchamacallit.
You're what?
I wired. Damn it. Okay,
Did you do
so
what I
see this? No, I freaking totally fucked up. So see this 1 meg right here?
Yeah.
I ran it across the pins from 2 to 7. So it is literally jumped from 2 to 7 on the tube socket.
Right.
Okay. Well, I have this one, this 0.1 right here
Yeah.
connected to pin. Guess what pin it's not connected to?
3, 7.
It's not connected to 7.
Well, it has to be.
Well, I didn't do it right. Well, no, it is
But
connected to
But
7.
if you look at it, that's
No, I did
your
do it right.
fucking negative feedback loop.
Wait a
bro.
minute. Then why isn't it? No, that I did do it right. I'm sorry. I'm looking at it
No,
wrong.
that's a negative feedback loop.
Yeah.
So if you have negative feedback, you'll hear that. Right?
Yeah. Yeah.
So you're on. I'm saying that. So
No, I did do it right. I just.
so you went from 2 to 7 directly with the 1M,
Mm-hmm.
and then from the 1M on one side goes to your 100, and through that 100 to the cathode.
Yeah, I have a black wire that goes underneath. You can't see it because it's hidden underneath the board, but it
But
goes.
it does go to your cathode in the voltage divider, right?
Yep, yep.
No, the other one, not there. The 2.2K to 22K to the 100 end.
Yep. Yep.
You have that one definitely going. And on the other
Uh-huh.
side, it's just going to go to your 100K, right to pin number. So look, that
So-
1M should connect to pin number 2 and pin number 3.
Mm-hmm. So this is what I got.
All right.
So I got
There's
that
your
going
1M.
there.
That's your 1M, right?
That's my 1M. It comes off of
And then-
here. Boop. And then this is my 100K here that goes to ground. So that wire
So
comes up
where's your 1M at?
right here.
Okay, so hold on. Your 1M goes to your cathode. Right out of the Yeah.
It's right, but something's going on for sure. I'm gonna have to go through it.
I don't think it's your phase inverter, but please put more voltage to that phase inverter. Max it out.
Well, so it's Riley. It's kind of a little backwards. So this is the anode, that's the grid. This is the cathode, and that's the anode, grid, cathode, right? So this is coming off the cathode. This is that 100K to ground that was here, right? 100,
Wait a second.
right, 100K to ground.
Wait a second, Luke. So look, so so off of pin number 3, you have a 100K to ground.
Mm-hmm.
Right off of 3 goes into pin number 2, and it goes to 100 down. That goes over to pin number 1 and a 100, right?
No.
Yes.
Over
So
here.
look, start from your cathode follower, right there.
Right there.
Your cathode follower.
Cathode.
Right? So that goes up to, right?
The
that
grid.
Goes to 2 places.
Yep.
That goes over to a grid.
That's this one.
That's a grid, and then it goes up to the 1M, right?
This is the 1M.
Ground.
Yep.
So that 1M goes to ground. Look, you have that 1M going to ground, right?
No. This right here. This is our 100K.
Right. Well, look at the 1M. What's that black wire? That's ground.
No, that's just the jumper. So that goes from my cathode to the grid.
No, up to your 1M. Show me your 1M resistor.
Right here. This one.
Where's the 1M?
That's the 1M right here.
Where? You said that's 100K.
No, this one is 100K.
Where's the 1M?
Right here. That's R16.
Right, so where's the 100K?
This one, R2.
R2 is the 100K.
Yes.
R16 is the 1M.
Yes.
The 1M, so you have the 1M going to so it goes right to your cap, right on one side of it.
Yep. Which touches on the other side to the negative feedback, which flows through this way.
Oh my God.
Yeah.
You didn't mark them.
No, I didn't label these.
So you come down here to the other 1M, and that's jumped across both sides. That goes over to your cathode. So that one goes to your 100K to ground. Yeah, that's good. So that your circuit, keep that open right there.
Mm-hmm.
Hold on.
I was pretty tricky in this layout here. A lot of people don't realize how much that one shows going into the grid. Yes. So just so you know, Riley, we're kind of, oh wow, we got 20 people watching us now. Yay. Okay, Riley. So it's kind of confusing because I didn't label these. This is my 0.01. That's that 0.01 that was over here.
All right, Luke, I want you to listen to what I say, and I want you to trace everything that I tell you that you're going to trace. Okay.
Oh, okay.
All right. I want you to go to V2, right? I want you to go with the master volume goes into 7 directly, right?
Right here.
I'm not going to look. You just tell me. I'm going to guide
right here.
you. So master volume goes into pin number 7.
Yep.
And on the bottom of that pin 8, you have a 2.2K to 47N.
Right here. Yep. It doesn't show it here, but that's the 2.2.
Two ground, right?
Yep. That's the ground.
And then on the top, you have a 100K plate resistor.
That's this. Which one is it? Right here. It's on the freaking tube socket right here.
Right, now check this out. The 100K plate resistor goes through a 22N into pin number 2 of your cathode follower. So from 100K into a 22N into pin number 2
of my cathode follower.
Yeah.
So yes, so right here is that little network.
And also at pin
and then
number
it comes.
2,
Yep.
It goes to a 560 and a 1M.
This is the 560 here. This is you can't really see it, but you can see it underneath there. That's the cap. That's the 0.022. That's the 1M. That's the 560.
Right, and then at the bottom, the front side of your 0.22 goes down into your presence control into a 1N.
Right here. That's this one.
Right.
Yep.
Right, and then you have the 100 ohm to R ground.
That's this one.
And then you have the 100N on the other side of the presence control.
That's this one.
Going into your negative feedback loop.
That's this one.
Which is a 10K 470 ohm and a 10N.
Mm-hmm.
And then that goes up to the middle of your 22 and 2.2K into your cathode.
Right here.
Right? That does go there, right?
Yep.
And then from there, it goes through another 100N, which is a 0.1, all the way up into pin number 7 and to a 1M resistor.
So
So the 1M resistor is going to be going across the tube sockets, you said.
that's this one
right?
here.
So the 100N does go to pin number 7, right?
Yep, right there.
And then your 1M goes from pin. So you have a connection going from pin number 2 to the cathode.
Pin number 2 to the cathode.
Yes, pin number 2 to the cathode of the cathode follower.
Yep, that's this one right here.
Yep, and then that's 100K to ground.
That's the 100K to ground right here.
Right, so the only thing that you have is low voltage on your plates. That's the only thing that you have in that. So look, where you're attenuating your circuit is not in that phase inverter.
Mm-hmm.
But I am telling you right now, you better get that voltage up on that phase inverter because it doesn't like low voltages. Because of that bias. Remember, that bias is fixed for 550 to 600 volts, maybe 650 volts. I loved high voltage, right?
Yeah.
So you're putting 350 out. How much do you have going into those plates?
I had, well, I don't know. We'd have to double check. I never did measure this voltage right here.
Yeah, and did you get those resistors? Well, even if you got the resistors mixed up, it wouldn't make it sound bad. It would just,
So it looks like I did wire it correctly, but hold on, I'm doing a thing right now. I'm putting a load in. That's what I'm doing. I'm turning on some power. I'm gonna go back to here. So I've got power on. Speaker in, no input, so we won't hear anything. I'm gonna turn the master volume is down. Ground, 600 volt. You can see that. There you go. Now you can see that.
You probably only got like 300, but I want to see before the resistor and after the
yeah.
resistor.
Okay. So just to get an idea of what we're working with here, at this point here, I got 406 volts, which is right about what I was thinking I was going to get.
406 going into the phase inverter?
No, I got 406 on my HT.
Right.
So,
I want to know what you're going into the phase inverter before the dropping resistors.
So right there, I've got 406. And on the other side, 379. So it drops about 20 volts.
Now I want you to measure the voltage after the droppers.
Well, that's right here.
Well, I'm not looking. So look, I want you to measure directly on pin number 1 and number 6 of the phase inverter.
1 and 6. So this is pin number 1. That makes a lot of noise.
Yeah.
So I got 350 volts on pin 1. Oh, you can't see that. There you go. 350 on pin 1.
You have 350 on pin 1 and then 258. So look, they only put out.
I got 338 on the other side.
So they only put out 280 volts and 258 volts.
Damn, that gets a lot of.
V4, hold on, V4. So 258 and 265 volts, V3. Yeah, you have way enough voltage, man.
Mm-hmm.
Because they were only putting out on the phase inverter 281 and 189.
Yeah.
No,
Well, when I hit the plate now, we get a lot of noise.
Well, you're gonna, because that phase inverter is working correctly, right? It's super loud. You're attenuating somewhere else in your circuit of your circuit.
It's somewhere in here.
Listen, I just verified everything. Like, you're getting a ton of noise when you're touching that plate. That means it's spiking that grid.
Yeah.
That means this. Whatever you're going into that signal, right? You attenuated your circuit, your guitar signal way too much prior. Somewhere.
It doesn't like that.
Fucker's loud, dude. So you can verify that by touching pin number 7 of your recovery tube. Or not 7, sorry. It'd be after your coupling cap of your recovery tube.
Yeah.
And well, you don't have a voltage source, right? But you could actually probably put a guitar in there and then strum. So you could put a guitar in there to verify all the way up to that recovery tube.
Yeah.
How much voltage you're actually pushing out of that tube.
Yeah.
Or into the tube, actually. No. It would be, if you looked at the high watt schematic one more time, go to your schematic.
Okay.
and then you want to.
Hold on, we're gonna hear an awful noise.
So you want to look at coming out of your master volume, bro. Right?
Yeah.
What is the voltage going out of your master volume into pin number 7 by strumming your guitar? It should be right around 1.3 volts, dude. AC.
Yeah. Probably be more than that, I think, but.
Well, I don't know. It won't be because, dude, if it's any less, you're attenuated. Because mine's right around 1.5 volts AC. You don't want to look at that's the recovery tube, right? Coming out of your tone. It's supposed to be coming out of a tone stack, right?
Yeah.
You're supposed to be coming out of that tone stack into that master. Out of that master, right? You're going to be because if you look, we talked about this a couple days ago. When we were designing my amp, the impedance load was going to be way so high, so I put a cathode follower there. But I ran a maximum amount of voltage going through the tone stack, but we have a huge loss. High watt tone stacks suck so much voltage.
Yeah.
Right, but they don't suck it all down, right? So 250 is what your guitar is. It probably is right around 1.2 volts going into that grid out of that master volume. You should have at least 1.2 volts. Right, coming when you plug your guitar in right now. If you plugged your guitar into the amplifier, right?
Yeah.
And you touch that master volume center, you should have 1.45 volts of AC when you strum.
Yeah. Okay.
If you 1 volt to 1.5 volts, I don't know, they're all different, but it's a pretty big signal going into it, right?
Yeah. Yeah.
It's not going to be as big. What I'm it's not that big. It's 1.1 volts, maybe 900 milliamps volts. Sorry, but when you come out of that and you go into your point 2, coming out of there, going into your first cathode follower, that's when it starts to stabilize itself, right? But it's a big voltage, man. And when I say big, I mean AC voltage, because you're attenuating. You're attenuating with a 1M to a 560 to ground.
Yeah.
Right? That's an attenuator. So that's attenuating that circuit coming out of that tube right around 50 to 60%. Right? Because that voltage coming out of that 22N without that attenuator hooked up to set that bias voltage, that is super big. It's like 7 volts, 9 volts AC. It's way too big, dude. So that's what that attenuator does. But if you're not, you can tell if your circuit is prior getting attenuated by looking at what's going into that grid of that recovery tube. Right? And if it's little voltage, if it's like 200 millivolts, it's not big enough. You need to get your circuit bigger.
Yeah, yeah.
I think you just got a resistor wrong, dude. I think you just have an attenuating resistor wrong, and one of the values is backwards. I personally think that's what you did.
Yeah.
Somewhere,
no, there's
because
something.
you have sound, and it sounds good. It's just not loud. So you're bleeding you're losing your signal somewhere.
Yeah.
How I usually find that is just lift each phase and then hook that directly right into that phase inverter. So I'll just basically disconnect the phase inverter right there at the master volume.
Yeah, yeah.
So I'll just disconnect the center master volume one, right?
And move it over.
Wire dangle, and then I'll just connect each. So then I'll go to the first stage, and I'll disconnect that going. I'll disconnect the output going to the next stage, and I'll just take a jumper wire alligator clip and just clip those together. Okay, I can verify that first stage works. Hook that one back up, then take the second stage and do it right to the past the master volume again. Verify that stage works. You have an attenuation going on before the phase inverter. It's not the phase inverter, dude.
Yeah.
You got a lot of I don't know how you got so much voltage those phase inverters, but you did good doing that, man.
Well, I mean, I did a bit of math. You know, I was shooting for some things. 350 volts on the dot right here. I mean, that's not too bad. Well, actually, I had 350 right here.
I don't know how you did that because, again, high watts run right into those phase inverters at like 550 volts right into the phase inverter.
Yeah.
And that brings it down to 250 volts. So I don't know how you got so much voltage there. If you went back to the technical page, go back to the Mark Huss technical page, the do-it-yourself page.
Okay.
Because this is what I don't understand this, and this is something that I don't understand. I built it many times, so let me go back to. So we'll go back to do-it-yourself. Technical page, main high watt page, do-it-yourself page. Go down to the voltage chart. Look at V3 is going to be your phase inverter on a high watt.
Okay.
Well, it's supposed to be. I don't know why they're using a CV4024. What the fuck is that?
I don't know. But yeah,
usually V3 is your phase inverter, and if you look, pin number 1 has 281 and pin number 6 has 189.
Yeah, and I did have a lower voltage on the pin 8 or pin 7.
So I think that pin 4. I think that what he's saying is V4. I think that's his phase inverter there. 258 and
265.
265. I think that's his phase inverter. So look how low they are, and that's coming in at 650 volts, man. Right? So I don't know how you got so much volts. You got double the volts. Well, a third of the volts more with less voltage. So is your plate resistors even the right value?
I have a 100K and an 82K.
Yeah, that's not the right value.
Well, they don't make a 91 in the ones that I got.
Yeah, they do. I got them right here.
Well, I mean, they don't make them in 91 in the Dale Vichiers.
So you got a Marshall you got the Marshall, right? They don't. So
yeah.
You got the Marshall phase inverter.
Pretty much, yeah.
Values.
Yeah.
That's probably why. I mean, I don't know why, but you're a third of the voltage higher than a high watt, dude. And a high watt starts with an increasingly more voltage, right? So they get a way bigger drop off those resistors than you're getting, which makes no sense to me. That means to me, you might not be fully conducting that tube.
Yeah.
Right.
So he's saying 2 caps right of center not connected. So keep in mind that some of these have underboard connections, Steven.
All right, well, listen, I think that your phase inverter is good, dude, other than the voltage seems kind of off. Other than that, it's before. You're going to have to, listen, I'm all to watch you, dude. I went through this. So, look, when I first fired my amp up, Luke, it didn't work.
Yeah. No, I know. It happens.
Dude, it didn't work. I didn't know I was doing the same thing as you, and the people were laughing, I'm sure. And then I switched the plate and the grid around, so the plate and the grid was bad, and I forgot a 1M resistor. Plugged it in, bam. But I will tell you this. You said you never heard an amp so quiet. I didn't even know my amp was on, dude.
Yeah.
My power section on. Didn't even hear it.
Yeah, no, this thing doesn't buzz. It doesn't hum.
It didn't buzz, didn't make a fucking peep until I hooked my fucking... Until
you got it working?
Preamp up, and then it was like, bang.
Yeah.
Well, it doesn't hum, it buzzes, dude. You can hear it, it hisses. It's like,
yeah.
But anyway, listen, I'm going to go. Sorry I couldn't help you.
No worries.
Your phase inverter, I wouldn't even fucking, other than those 2 resistors, it's not your phase inverter where you're losing. You just heard it. When you touched your plates, it was loud as fuck, dude.
Yeah.
And that means you're getting full signal out of those phase inverters.
Yeah. No, I think so. We'll figure it out.
Go back and unattenuate some of your shit.
Yeah, right. Well, we'll figure it out. There's something between here and there, but we'll get it dialed. Definitely going to figure things out. We'll talk to you soon. Bye. All right. So you guys kind of heard it. It looks schematically like I didn't really mess too much up. So I went with a 200 ohm here, not a 220. I have the 6.8. At the C node, I'm getting 350. Well, I should say at the pin of right here, like at the pin, I'm technically getting, on the pin, like literally on the pin, I'm getting 350 volts on one side and a little bit less on the other side. The negative feedback is weird in this amp. So it comes off of the 16 ohm tap, which I'm coming on. Don't worry about the bass pot right now. We know that works. I've confirmed that the bass pot works. So we come off the 16 ohm tap, and I'll show you what I got going on here. We'll bounce back and forth a bit. This is the 10K here. Get this out of the way. All right, so let me get a pointer. And something a little bit easier to see than my finger. All right, so this is the 10K right there, okay? Then this is our 470 ohm and our 0.01 to ground, okay? So we're sussing out the negative feedback, right? So that's the 10K that you just saw me pointing at. That was the 470 ohm and the 0.1 to ground, okay? Then on the other side, you can see here, from there, it goes up and into the phase inverter up in here, right? It literally touches the 2.2K and the 22K. It goes right into the middle of that. So if we go in here, that's this point right here. That point comes out and around and it jumps into right there. It goes up and then it does like this little jump right through here. So this pin right here jumps to right there. That is the 22K and that 2.1K. That is the other side of that 0.1, okay? So the other side of that 0.1, which comes down back here, is the one that touches the pin, what would be basically pin 7, which it does. It drops straight down and goes to pin 7, and then it goes across that resistor right there. You guys can't see, 'cause I'm moving my cursor around. Okay, whatever, sorry. Right here, this is that negative feedback loop that jumps in from right here. This one here goes to ground over here, okay? So this jumps around, goes to here, goes up and across, and then it jumps across all three here. So it literally goes from this one to that one to that one. This is that 22K and 2.2K junction. This is ground right there, okay? So this one here is the one that goes to the cathode. That's pin 8. This is the one that goes to the grid, which is what jumps across with this 1 meg to go to the other grid, which then touches in at the cathode across the way. I wish I could show you both at the same time. But then this guy right here also shares, it jumps off to another 0.1. So what I can tell you based on, hold on, I'll show you what I'm talking about here. Okay, so this is that other 0.1 I was talking about right there, okay? It should be, once we actually get it to work proper. We know that it makes some noise. It makes a lot of noise when you shut it down. So I also noticed that when I touch this grid, oh, you can't see it because I'm not there. All right, so this is that 0.1. The 0.1 goes into a 100K pot, and then on the other side we got a 0.01 that then feeds back into the negative feedback loop, which is right here, okay? So this guy here jumps over to here, jumps over to here, which jumps to there, goes through the 100K pot, which comes back through here, into here, and then this guy goes, let me confirm here. Actually, I guess it would just be easier to show you this way. Hold on, because I know that this is wired the same, okay? All right, so get up, it's gonna make me work, sorry. All right, so basically same I was showing you. There it is. All right, so that's that center point, jumps over, goes up, touches all three of those. This is a 0.1, goes into that. This is exactly what I got. I have volume, we have sound, but it's just, what's the term for it? It's very distorted and it's not loud at all. Like you can turn the master volume all the way up and something's obviously not chooching. So that goes up. This is the 22K, that's the 2.1K. Goes through, this is a 0.1. It jumps over, goes through this other 0.1 here. This 0.1 jumps up and goes into the 100K pot, 560 to ground, comes out of that 5K or 100K pot over to this side of the this 0.01, I believe it is, if I'm not mistaken. So 102.001, and I believe that is correct. 0.001, yep, there it is, right? So 0.001. And then that 0.001 goes directly to the cathode. Let's see if maybe that's where I got it wrong. That goes into the cathode. No, anode, excuse me. Sorry. Goes directly into the anode of that other tube. So if we follow this up, oh, maybe that's where I'm missing it, but I wonder if that's where I'm biffing it. No, that's the anode. Yeah, sorry. That is correct. It goes directly into the anode of that tube. So yay. Are the two caps? I see no connection to pot. Let's go back to what you're talking about. C10 and C11. These ones here, they jump. They jump over here. So on my board, you can't see that because they're under board connections. These go to dual pot over there. And I have confirmed those connections. Those are good because this pot does work. So there's something else going on there. But so yeah, that goes directly to the anode of our driver stage, if you will. So we can confirm that by looking at this here. That is our driver stage of our, I basically inverted this tube, if you will. So it looks kind of backwards, but it's not. So this is the 100K that comes in on that tube, right? So this is where it feeds in from the other side. This is that 100K dropper, and then this is where it comes in at. This has two pots in there, or not two pots, two components. There is a 0.022 and I can't remember what it is, whatever the 1 meg or something I think it is. That is this network right here. It's a 1 meg and a 0.022, all right? So it comes in, and those all connect together with that 560, okay? So that connects right there to that 560. From that 560, it jumps down into the grid, right? So it comes into the grid after that network right there. This is our grid leak right here. That's the 560. Does that make sense? So we come in. This is a negative feedback. It goes through the 1 meg and the 0.022, which both touch in at the grid of that second side. All right? Goes through the 1 meg and 0.022, which comes into the grid on the other side. That other side's cathode jumps straight over into the phase inverter. So there's nothing wrong in this portion of the circuit as far as I can tell. The only other way, I mean, obviously there's something when you turn it off, because if I turn the master volume all the way down, negative feedback going to C16 or a new pi tube. I don't think it's the pi tube, but I mean, there's no telling. It could be. It's just weird that when you turn it off, it makes that awful freaking noise. Like, that is not a fun sound when you turn it off. And it should definitely not do that. Everything looks fine here. It could be the bias circuit injecting itself through the amp before it turns itself off, but I find that hard to believe. The tubes are not red plating. They don't seem to be too hot. Freaking little bug. So I think my problem is kind of from this point forward. Like, something in this general vicinity has come apart for me. High plate voltages and the triode is not conducting current. So far everything seems to be doing what it's supposed to, but I haven't really confirmed that the phase inverter is doing what it's supposed to do either. Keep in mind, I did forget. So when I was putting this together, I forgot to put those two wires in right there. Somehow or another. No, I put this one in. I put that one in, but I forgot to put this wire in and that wire in. So this wire here, somehow I managed to forget to put in, and this wire here. So I had no cathode at first. I'll roll the tubes. I can do that. So here, I'll spin my amp around so I can see them. And wow, that little fucking bug is quick. Fucking thing. All right, so I'm gonna replace it with different tube, and we're gonna stuff it back up in there in some other spot. So I now have a different tube in the phase inverter hole, and now I gotta get this one back up in the other freaking spot. Not that it matters at this point, but so like I say, I'm relatively positive everything's wired correctly. Sans, I've never built this circuit before, so I don't know what is supposed to be unpissed off or whatnot. It will work. We know it makes noise, so that's not the problem. It is quiet. That's another good thing too. There's no hum and buzz. So that is also another positive. All right, power is off. That is there. I'm going to go ahead and put an input into it. You guys can't see what I'm doing. I apologize. Master volume is down currently, but all right, amp is getting turned on. The amp is on. And here we go. So we can see that the amp is on. And here's the whatchamacallit. And if I turn up the master volume, and this and that, so if I turn the pre-gain up all the way, you can hear it buzz when I touch it. And it turns off when I turn this one down. And it works with that one as well. Master volume is working. Presence works. Can't really hear anything to tell that's working, but and that's it, just pissed off because it should be. So there's something in the circuit somewhere that's really pissed off. It just doesn't like it. If I touch the plates of the thing, it's just. So it makes noise. That's anyway, I don't hear any buzz on the output, so whatever I did there is fine. Except for when I turn it off, it makes this awful noise. It's not a very fun sound when you turn it off. So that I got to figure out too, because that sucks. So there's a couple little bugs I got to work out. I'm pretty sure that the grounding circuit is fine. I shouldn't have any problems there. Shouldn't. So we're going to just have to do some sussing out and finding where all the weak parts are, because obviously something is not doing what it's supposed to. The fact that it passes signal leads me to believe one of two things. And I don't have any heat coming out of anything. The tubes are running ice cold right now because we got them biased pretty quiet, but yeah, there's no heat being generated anywhere. Even my screens are cold, so things seem to be working right. Let's see here. Yeah, that's even cold. So there's nothing wrong majorly that I can see. Let's see here. Nope, cold. Ice cold. What about this one? I'm kidding. Yeah, ice cold. So circuit-wise, everything seems to be just dandy. So we'll figure it out. Little by little, we're just going to weed it out. But I guess we'll call that for tonight. We made some noise. Obviously, we know it will make noise. There's just something somewhere that's pissed off. and I'm gonna have to figure it out. So we know we can do it. But I'm gonna call it there, you guys. It's been what, 2 hours 30 minutes just about. Today's just not been my day all the way around. I thank you guys for hanging out with me though, and never fear, this thing will work. It's just a matter of finding out what it is that isn't working right. Could be a couple different things. That's correct. That is also correct. Maybe not. I don't know. I'll confirm a few things. There's one spot here that I'm looking at that could be what my problem is, but I don't know. I'll have to work it out. So anyway, thank you all so much. We'll see you on the next one. Take care. Goodbye.